Okay, so I'm looking here at which of the following statements regarding curly braces is not correct as they relate to their use with an if statement. So definitely confusing. Yes. Am I? You don't want to see that? It's probably not super helpful. Well, darn. It's decided to switch their numbers. Okay. Thank you. It's number 2 now. I like that better. So back to our question. Which of the following statements regarding curly braces is not correct as they relate to their use with an if statement? So first of all, whenever we're working with a negative question, we have to stop and really think about it because it can be so confusing, and accidentally we can answer the first question or use the first answer that seems right. All right, so are curly braces required when there is more than one statement following an if or an else? Yes. Can they be added just to increase readability, even if they're not necessary? Yes. Can they be used to block 3 or more statements? No, so they just kind of made that up. And then the last one, they can be used with the true statements and omitted with the false. So if we had multiple lines of code to execute, if the if statement were true and only one with the else, we could leave them out. So be aware of that one. Really good on all of these. Okay, this one. We have an if statement. If we put accidentally a semicolon onto the end of it, what's going to happen? You can tell what they say. Do you believe it? I had to open Visual Studio and try it because I was like, doesn't it give you a syntax error now? Let's try it and see. It's okay. I brought up some code that has a bunch of if statements, and if I add a semicolon, it does start warning me, and I do get the green squiggly. So it gives me a warning. This is possibly mistaken, but it doesn't give us a syntax error. So it'll let us go ahead and use it that way if we want to, which we shouldn't. So be really careful of that one because that kind of error can cause a lot of trouble in our code too. And just to emphasize it, we'll see that a few more times. Okay, everybody did really good on this. Number, whatever this is. When you compare characters stored in char memory locations using relational operators. They obviously want this one. They're compared lexicographically. What does that mean?
Does it look at the ASCII value?
ASCII value in order, the dictionary. So it would be in dictionary order. So that's what we're always looking for when we're talking about character data, whether it's char or strings. This one, take a look at, just because a few people got it wrong. The majority of people got it right. We've got phone digit with a value of Q. So which case path is that going to take then?
The default.
The default. So that's why we're going to end up with num equal to 0, because we don't ever see Q in any of our case statements. Next one, which of the following statements is not true regarding switch statements? The default is not required. Okay, why does this say the excellent is going to be output every time the program is run instead of when the if statement is true, like some of our people assume? What is going on there? Do you see it?
It's not in the curly braces.
There are no curly braces, right? So since there are no curly braces, how many lines of code are going to be executed as part of our if statement? Just one. So it doesn't matter how they're indented. It just matters that since there's no curly braces, we'll just do one line of code. It's not Python, exactly. So this statement would really be outdented if we were thinking about it that way. Taking advantage of those Python knowledge. What's the rule for lining up or matching else's? This is a really good way of putting it. The else goes with the closest previous if it does not already have its own else. Okay, another if statement where we had a lot of people misinterpret it. What is it about this if statement that's going to cause the grade to be set to A every time the program is run?
It has the semicolon at the end of it.
Right, we do have that bad semicolon at the end of our if statement. So the if statement is in effect null, it does nothing. And that next line of code will always run. Good, good, good. See, there's just a few questions that got us. All right. The expression 5 greater than 57 modulus 8 evaluates to what? What's going to happen first? The modulus is going to result in 1. So is 5 greater than 1?
Yes.
Yes. Sentinel controlled loops are the type where we say enter 99 to end. So that's the kind where the user has to type what we want to make it end. Now this next one, let's take a look at. Got pretty well split here on this one. Instead of requiring that a dummy value be entered after all values are processed, a blank controlled loop initializes a variable on the outside of the loop and then evaluates the variable to see when it changes values. Its value is changed inside the loop body when the loop should exit. Very interesting way of putting it. They're looking for state because in a state controlled loop, we would use a Boolean variable to control our loop and change its value when some condition occurred, like the user entered minus 99. So we could make our loop state controlled, and we'll get more practice with that. Off by 1 is always our error with looping. How many times will this loop body be executed?
I'm going to guess 5.
Since that's the right answer, that's a good guess. There's some tricks we can use when we're taking an exam like this. Since our loop variable is starting out at 0 and we have a condition of running while we're less than 5, we know it's going to run 5 times, right? If that conditional was changed to less than or equal, we know it's going to run 6 times. So we can always tell it's going to run the number of times of the condition, unless there's an equal sign, in which case we'd have to add an additional loop iteration. Okay, let's take a look at this one here. It's kind of ugly. They say an example for statement that has a compound initialization, meaning more than one variable is initialized. It has a compound test and a compound update. It could be written as, why is this one correct? We start out saying we want to declare an integer named R with an initial value of 0 and an integer named C with an initial value of 5.
It's the only one with the compound initialization.
It's the only one with the comma there so that we can tell that's a second step of initialization. Exactly. In the middle, the R2, it's kind of like compressed. We're not seeing the whole condition there because that's not really where they're wanting us to focus. So sometimes we have to focus on certain areas. And then again, at the end, we have 2 examples that have a comma between the different updates. So both of those are correct. On the update step, we have to return back to the initialization step to find the right answer. Okay, another one with how many will this loop body, how many times? Again, we're starting at 0, running while we're less than 5. So 5 would be our answer. If we started at 1, our answer would be 4. If we had less than or equal, we would have to add 1. So really think about how that is always going to be really consistent. We're going to use our for each statement a lot as we look at arrays, so we'll get a lot more practice with some of these things. You guys just did a great job just jumping right in there, throwing you in. I think those were the main ones, because most of the ones that got people are the ones that are kind of designed as, I would say, a little tricky. And they are a little tricky because they're such important concepts, not to really be sneaky to you. I'm going to download our presentation for array structures. And if you look at our modules, this would be lesson 11. And I'm looking at this special PowerPoint array. The array from that PDF book that I keep attaching to things is also included here if you want to refer to it. But I'm going to look at this other one. Wake you up with brightness. It is bright. We're so ready today.
Maybe.
Whenever we work with array structures in C#, we're working with a collection, and there are lots and lots of different classes available that help us keep track of collections. So we're going to start with the most basic collection class, which means it's also the most limiting. So as we work with arrays, remember, these are the most limiting structures that C# has for collections. We just want to know how to use them first, and then we can use the more advanced ones and take advantage of their features. So when we're working with arrays, some things to be thinking of or remember: array structures are just variables, but they hold repeating data. They allow us to more efficiently save our information. When we're working with C#, the array must be allocated. We must say how big it's going to be before it can be used. So that's a little bit different of a requirement than, say, Python. It limits us. All entries in the array have to be the same data type. So if I say this array is integers, everything in there has to be an integer. I can't mix them up. Once my array is allocated, the size can't change. So I could allocate a new one, copy everything to it, get rid of the old one, but I can't change dynamically the size. So let's think about some variables when we're working with C#. We've seen all sorts. We could have a double that holds a percent, and an integer that holds age, a string that holds a name. There's a decimal variable with an initial value and a Boolean. So all of our different data types could be set up as collections. So if I want to create an array, when I'm working with C#, just like a lot of our other programming languages, the square braces, the square brackets, are what indicate to the system that we're talking about an array, a repeating occurrence of things. So this statement would create an array named name that contains 5 strings. So here could be my array if I have loaded some data into it. Now, when we're working with an array, some things that we want to be thinking about, we can, sometimes I like thinking about an array visually as stacked like this. And in a lot of textbooks, you'll see it go across. Either one is fine, it's just kind of a different way of visualizing it. But no matter how I visualize it, when I'm working with an array, internally, I'm going to have a virtual index. And an index is just a pointer into my array so that I know what position in the array I want to look at. When I'm working with C#, my indexes always begin with 0. So as a software developer, you might have seen some jokes about how we always start counting at 0. That's true. We try to always start counting at 0. One time I just had a terrible problem at work I couldn't get figured out. And I went to the systems software guy who took care of all of the really high-end stuff. And he was looking at things for me, and he started counting. And he got to the number 9, and then he went A, B, C, because he was counting in hex. And I was like, I forgot. I needed to be counting in hex. So we start at 0. We use all these weird number systems. Things like that can give us trouble. But our indexes always begin with 0. So that's something consistent that we can depend on. So if I'm looking for that entry Tammy in my array, that would be index number 2 of my array. So I could refer to this entry as the array name followed by the index value of 2. So I'm looking at array name, index value 2 to find Tammy. If I wanted to change Tammy's name or the name at index location 2 to a new name, I could use a line of code like this. I want to use the array named name, and at index location 2, I want to set that value equal to this value new name, and that would update that value in the array. Now, our array is just a collection of data. Let's see, PowerPoint, I'll probably have this messed up, we'll try it. But up at the top is a line of code that's a little bit different than what I showed you earlier to allocate an array. This line of code allocates an array of integers. The array is named age. These values, 16, 25, 29, 24, and 14, are going to be loaded as initial values into the array. So I can picture it in memory kind of like this. So at index location 0, I have the value 16. In index location 1, I have the value 45, and so on. So my array is all allocated. It's giving me the ability to keep track of all of those different ages. We'll say those are people's ages because we already had a list of people. Now, this array has to be allocated out of contiguous memory. What does that mean, contiguous? Can I have holes around? Can I just take a piece? No, it has to all be together. So if I have an array that has 1 million entries, how much memory am I going to use? A lot. So I have to always remember that it's going to be contiguous. Maybe I shouldn't have 1,000,000 entries. We'll see. So my index is going to be taken care of automatically for me. We don't do anything about that. We in our code are more concerned with the value retained in our array. Here's a little chunk of code where we create this age array, and then we just write out 3 of the different lines. The age at position 4, the age at position 0. Now what would happen if we tried to write out the age at index location 5? Out of range. So yeah, so it would let us compile. It wouldn't give us a syntax error, but it'll cancel when we go to run, because it'll say you're trying to access your array out of its range, outside of its memory locations. So that's a new thing that we have to be aware of, that we have to be careful of. So this is an array with initialization included. Our data type of integer is followed by our square brackets. Then we have the name or identifier that we want to assign to our array. Then we have our initial values. Our initial values are separated or within curly braces, separated by commas, and they are used to determine the size of the array. So in C#, I'm going to go back here for a second. This array is going to be 1, 2, 3, 4, 5 entries long, and my valid index values will be 0 through 4 to get to those 5 values. I cannot say age.add to add a 6th value to that array. It is limited in size. It has been created at that size. So it will, now I can change the values of those positions that are allocated, but I can't just add a new one.
Couldn't you push a value to it like other languages?
Do what?
Couldn't you like push a value to it like other languages? They could push something over it.
No. You cannot make it any bigger. So once it's allocated, that's the limit of its size. So no pushing or adding. We can use other C# structures to do that, but with a basic array, we can't. And a basic array uses the least amount of memory, so we always want to be trading that off. So here we have some syntax. We create an array called age, an array of integers. Seems like it's missing some square brackets there. That line of code might be a little bit of a problem. But then we create a variable called oneAge, and we use it to save the entry at index position 3. Because we want to access our array, we're going to use our array name and our index pointer. Our pointer is going to be within the square brackets, and then our variable is going to hold the value at that location. Now, if we want to update the value at that age array, say at index position 2, we would specify age at index position 2 equals 28, and that would change the value. Again, we're using the array name, the pointer within square brackets, and our new value. Whenever we have a collection, one thing that we have to do often as developers is look at every value in our collection, do something to process it. Think about it as a bank account. If you have your bank account and you made 7 deposits today, we want that collection processed, every single one of them. So we can refer to that as like walking the array or traversing the array. Here, different terms used for that. But here's an example. We have our age array and we've allocated it and initialized it with values. So here's what it looks like in memory, our index values and then our data values. Here we have some code, a for loop that's going to write out each entry. Let's create this code. Let's go ahead and do it ourselves so we have it. Let's open Visual Studio. And let's create a new solution. So let's see, I'm gonna want, this project name is gonna be array for loop. How's that? And let's make our solution name something different. We'll call it array practice. If you want to add to source control, you might want to click on your Team Explorer. Whoops, you'd have to cancel here and make sure you're connected to TFS properly. Or you can just leave that unchecked, create the project, and then make sure you're connected to TFS and push it. Checking it in. So let's see, just a little teeny bit of code here. We're going to create an array of integers. So int is going to be our data type. Our array is going to be called age, and then we want to give it these initial values: 16, 45, 29, 24, doesn't matter what that last one was, and 14. And that's going to finish our array. So let's put a comment or two there. We're actually doing two steps. We're allocating our array or dimensioning it, and then we're initializing it with values. And we'll see as we look at some of our examples that we don't have to do both of those things together. Now we're going to use a for loop to traverse our array. In our for loop, we'll use an integer named I, and I, short for index, is a common variable name for our for loops when we're processing an array. We want to start with I at 0, and we want to run while I is less than the size of our array. Well, we can use a system method or a system property called length to know how big our array is. So dot length is a property of the array class. Our array instance named age can access that property, right? Because it's an array. So it's part of the array class. Now, what do we want to do in that for loop? Our for loop is going to be controlled by the length of our array. And for each time we execute our for loop, we're going to output that array value. Our array name is age, and we want to output the entry at index position that equals our I variable. So let's run that. I'm going to control F5 so it doesn't disappear on me. And what I should see is each of my array entries printed out. So everybody got it? Does it work? So we're going to add more Now, should we add an additional write line? Let's do it. I want it to be before that value. And let's say we're going to output the index value is now our I variable. And since I want to do our output that way, I'll put the $sign before my beginning double quote. Okay, so now I should see a message telling me what index we're working on, and then output from the value that's stored in the array. So the index value is now 0, gives me the value 16. The index value is now 1, gives me the value 45. So we can see, we can get a little bit more practice with looping as we work with our arrays because we have to do so much with them. Okay, if that's working for everybody, hang on and we'll come right back to it. So that way of traversing the array uses a for loop. In our for loop, we're setting up an integer to be our index value, and we're controlling it kind of manually, how big it can get. Oh, I got amazing animation here. Go past it. We did that ourselves. Okay, now when we were looking at that previous example with our for loop, we're able to output the value of I and the value of the data that's stored in our index at that location. We can use the for each syntax though, and the for each syntax makes processing our array tons easier. So with the for each loop, we're going to use this syntax here where we use the for each keyword and say we're looking in this collection. Now let's look at this beautiful animation before we do our example. We have our same array. When we process it using a for each loop, notice how we're not really seeing anything. I'm going to go back here to this one. In this one, let's back it all the way up. Our code is doing a for loop. So as we start, we set I to 0. See it shake at you there? And we have that value of 16 that comes out of our write line statement. Then when we execute the loop again, I becomes 1, and we output the value 45. I becomes 2, we output the value 29. I becomes 3, we output its value, and finally I becomes 4. Now, why is that important enough for me to go through that again? Because when we're using a for each loop, it's not the same. When we use the for each loop, we're not going to see any index value. We're just going to see the data value. So in my for each loop, I can output the value is 16, the value is 45, the value is 29, the value is 24. And C# is going to take care of that for me, and it's super handy. But I'm not going to know necessarily what the index value is associated with each of those array entries. So let's write that code and see what the difference is. So I'm going to put this after our for loop. I think I will go ahead and do a console.writeLine and say, here comes the for each loop. Now, a for each loop is just a great way to handle a collection. That's what it's designed for. So in a for each loop, I'm going to say for each as my keyword. Then within parentheses, I'm going to specify the data type of the things that I'm going to process. our things are integers. And for each of the entries in our array, let's refer to them as a name called entry. So for each integer entry in our array age, we can output. Now, instead of outputting using our array name and the index value, we would output that entry. So each item in the collection becomes entry. Now let's try running that. Control F5. So for our first for loop, we've got the index value and our array values. And then we have our for each loop, where we just again printed out each of the values. In our for each loop, could we print out this line, the index value is now? No. Right now, we don't have that capability. We could add more code to make it happen. We could keep our track of our own counter or something to figure it out. But with our for each loop, we would have to add more code to make that happen. So the for each loop is very, very helpful, but it does limit what we see. Another thing about the for each loop is it is read only. So I would not be able to update any of the entries in my collection as I'm processing them. Whereas with our for loop, if we decide that entry number 3 needs to be changed, we can change it. So lots of ways. So in a for each loop, for each is our keyword. Our criteria is contained within parentheses. In is a required keyword here. And after the keyword in, we have to have our collection name. Before that, we need the data type of our array, the variable name to hold each array entry, and then our actual array. So all of these things get pulled together. Now, the two arrays that we had in this example, we had the string array with the user's name, and then an int array with their age. These two arrays, if they're working together, are called parallel arrays. So parallel arrays are, since I can only have one data type in an array, I couldn't have this age value within my string array. So I can have these two arrays and I just keep them in sync. So I know if I'm looking at index value 3 in the name array, it's Vera. So I can look at that same index value in the array, age array, and find out that Vera is 24. So they're parallel arrays working together. Let's put those in our program. So I have this age array. Let's allocate another array of strings. And so this string array will be name. And our names that we had, since we're working with strings now, each of these entries are going to be contained within double quotes. We're going to have Joe. Short names here. Short names are key. Bill. We have new name. That name is a little long. Vera. And finally, Austin. And then my closing, semicolon, to end that array declaration. So for our first for loop here, we'd be fine. We can output the user's name, right? We already have an index. So let's say we could just update our right line statement where we output their age, and we could make it be a little bit more involved. Let's add the $sign, and let's say we're going to make this message say, first of all, user, and then our name array using our index value of I. And we'll say we're going to say user name is age years old. How's that? So since we already are using an index here, our index value of I, we can just use that to access values in both arrays, these parallel arrays. So now we're going to output their name and their age together. Let's run that. I'm going to press Control F5, making it kind of messy here, but the index value is now 0. User Joe is 16 years old. For index value 1, Bill is 45 years old. Let's make sure those are right. Looks like it so far. New name is 29. Vera is 24. Austin is 14. Great. Perfect. So now what about our for each loop? With our parallel arrays, we have trouble. Right? We wouldn't be able to do our for each loop, so it's limited. So we're not going to be able to take advantage of that situation. But we could do some other things with it. We could set up a counter and keep track of what position we're at so that we could access the parallel array using the counter. I don't want to mess up our code doing that too bad yet. We'll do that here in a bit. So let's go back to what we were working on. Our parallel arrays, we've got those working in our code without any problem. Okay, the messy stuff. Whenever we are talking about calling a method or a function, it's always confusing to programmers, to beginning programmers, when we pass arguments in, parameters to our methods. So let's look at this kind of example here. In our main method, we have this line of code. It declares an integer named new int. New int is initialized with the value returned by the update int method. The update int method requires two parameters, an integer and a double. Right down here is the actual update int method. Here's its header. It returns an integer. It's update int. It requires an integer and a double. So these values, these arguments will be passed in to fill in these parameters as we run. So out here, my int value has a value of 12. A double has a value of 2.5. Those values will be passed in to the update int method. The update int method will do some stuff and return a value of 30. When we're using the standard passing by value that C# and most programming languages use, we're used to none of these variables being affected by the code within this method, right? We take this value, number 12, and we pass it in, and it becomes the value for this integer num within our method. Whatever this method does to it, we don't care, right? All we care about is what gets returned out of that method, and we're going to use that as our new int value. But our myInt and a double will never be affected because they're passed by value. We only pass the value that they contain into the method. And if you remember this from your beginning programming books, they just go on and on about it. And it makes no sense because we don't have any way to experiment with it. Let's look at this code here and you'll see we have a main. It declares an integer and sets it to 12. It declares a double and sets it to 2.5. And then it uses update int to set the value of our new int. So something that we've been doing a lot. We don't care what happens in update int. It's our black box method. We just care what gets returned out of it. We're passing by value. Now, passing by reference is a little different. You guys have seen it a little bit. You saw that out parameter in the try parse statement. The out parameter is that makes this happen, passing by reference. When I pass by value, I am creating a new variable in memory and loading it with the value of the other variable. When I pass by reference, I'm not. When I pass by reference, I'm using the same exact location in memory. So now when I update something in the method, it is updated when I get back. So let's look at this one. Here we have a main method. And again, this variable new integer gets initialized from the update int method. But the update int method expects an array of integers to be passed to it now. Here's our array of integers. It has these values. It gets passed in. Now, when it gets passed in, the data doesn't get copied. The values don't get copied. The actual memory location of this array gets passed and is now used by this method. So if this method decides to update all of these values in this array, they are updated in the main when it returns. So anytime we use an array, it's always going to be passed by reference. So here's an example. We're returning a sum out of our array, but if we were to update it, it would be updated. We're going to have to try it in our code. Let's try it. Before we do so, a couple of things about the array class. We'll finish up here before we try that. Whenever we create an array, we are using the array class, the C# array class. So our array that we create is a child of the system class array. That's why we could use that .length property, because the system class array has a .length property. When we create an array, we can use it. Some other things that we can use from the array class, we could use array.sort to sort an array. We could use array.reverse to reverse the order of entries. We could use array.getValue to get the value at a specific index if we didn't want to use the square brackets to access things. So a little bit of differences. So arrays are awesome. They're kind of limiting with C#, but they give us a really good example of how we can get started, and they are the most efficient. So if I need to use something that's a collection in C#, I'm going to be more efficient memory-wise if I use an array over some of the more advanced classes that we'll see as we move on. Okay, so let's look at our practice program. I want to do a little bit more here. In our array practice. This one is getting kind of messy, so I think we should start a new project if that's okay. Let's rename our program.cs here to be array for loop. And then on your solution, right click and add a new project. And let's make this one array for each. And we've already got a for each loop in this example. So we'll do things a little different. Let's rename our program.cs to be array for each. So first, I want to declare our integer array. I'm just going to declare it, though. I'm not going to dimension it or initialize it. And then, oops, our other one was strings. And we'll go ahead and initialize it. What did we have? I'll go copy them. Now I'm going to dimension our age array, and we'll make it the same size as the name array. Now to dimension it, whoops, sorry, I'm just going to specify its name, and because we've already declared that it's an array of integers. So now I just have to say that it is a new array of integers. And how many? Well, I want it to be the same size as our name array. So whenever I dimension an array separately, I'm going to specify the size of the array within the square brackets after the new keyword. Now let's set up some values in our age array. We had, let's see, the first age was 16. And I'm going to put this in this way, the least efficient, most awful, most clunkety way that I could possibly code this, which is not what we want. But sometimes it's the best when we do it at first, when we're doing it really simple. 29. And let's see what our last one is. I don't care what it is. We'll just make it the same. 14. Now I want to make this project my startup project. So my array for each I'm going to set as my startup. And then I'm going to use Control F5 to make sure I don't have any sort of errors or anything yet. It should be telling me. Looks good. And the reason I wanted to do that was because now what happens if I put in an index that's too large? I want you to see how it crashes. Press Control F5 again. And now you should see the system index out of range exception. So anytime you get that error, that means that we were trying to access a spot in our array that is not in our array. It's either before our array begins, if we had some sort of negative value, or after our array ends. Okay, so now we've got our ages all set up in our age array. And we saw that we could run that for each loop. Let's change our for each loop to use our name array as a control instead of the age. So that means we're going to be using strings. And we'll say each of those is going to be a person in our name array. I want to go ahead and set up an index to get the right age for that person. And then I'll just output all of that information. Console.writeLine. And first we want our person. I got an extra square bracket. So our person is age, and then for age, we want to use our index variable to get the right age, years old. Close that curly brace. So our for each loop is giving us this person variable. This person variable is going to be each entry that it finds in our name collection. So as we loop through, we're going to output that person and their age. So let's do Control F5 and try it. Oops, I've got to get rid of this one that makes it explode, huh? Okay, I've got Joe is 16 years old. Bill is 16 years old. That doesn't seem right. What's the problem there?
We need to include the index.
We need to increment the index. Sounds good. Index plus plus. Control F5. Still 16.
That's setting it equal to 0 every time it runs.
Every time it runs. So what should I do with that? Put it outside. Let's move it. That should do better. Now we've got our two parallel arrays. Joe is 16, Bill is 45. Oh, that looks much better. So I think that I would like to pass our arrays in to a method so that we could try printing things out. So let me label some closing curly braces. Here's the end of our for each and the end of our main method. End of our solution, and finally the end of our class. Now, why did I want to do that? Well, I want to create a new method, and I want to make sure that it's right after the ending of the main method, so we don't have any curly brace issues. So I wanted to get everything labeled so it would be in the right place. So right after the end of our main method, let's create a new void method, and this is going to be called output arrays. And we're going to pass to this our integer array called ages and our string array called names. So notice how when I'm using an array as a parameter, I do it just in exactly the same way I would do it without an array, except I just add those square brackets, and that indicates to C# that this is an array of integers instead of just one. I'm going to move this for each down to our method. I better move this index down to our method. Why do I still have these errors? Isn't our array named name?
Because it doesn't match
What should it be?
name.
Names. Okay. What about our age array?
Has been passed to the unit with.
Ages. So I named them just enough different to be annoying. So now those are the same arrays. So let's use our method. Put some code up here in our main. Call our method, and our method is output arrays. And we're going to use our age array and our name array. I've got to make it static. Sorry. Because I'm here messing with the main, huh? All right, so we got our method set up now. We're going to output both of those arrays. We have our age array and our name array. Let's try it. Okay, it looks like everything's good. We put that method in without causing any trouble. All our different people. Now I'm going to create another method. Static void update array. And we're going to pass this our integer array of ages. It doesn't care about our names array. So how could I write a loop that would like update everybody's age by 10 years? What kind of for statement would I need? For, do I want an integer?
For int array, or array.
I'm going to start with 0. I'm going to use my ages. Good. Length is my control variable, and I'm going to add to I. For each time I execute that for loop, then my ages array, I want to set it to the current value plus 10. I'll do some labeling here. So in our main where we call our output arrays, let's add another line of code to call update array. And we want to pass it our age array. And then let's output our arrays again. And what we're wanting to notice here is that in our update array method, the array is passed by reference. So it is updated. So we're going to see that update's going to occur not only in that method, but when we return to our main, our age array will be updated. Okay, let's press Control F5 to run it. So our first time through, Joe is 16, Bill is 45, everybody's right. We call our update array method. And then when we output our arrays again, we see that our age array has been updated, even though we didn't return it as an updated array to our caller. Let's go ahead and set it up in the debugger. How about we start, I'm going to start on line 13. That's very beginning here. Come on, where are you? Oh, it won't let me. I can do the next line because I just declare the variable there. It's not a valid line for a breakpoint. Now I'm going to start running. And down here at the bottom, looking at my local screen, I'm going to watch as things get allocated. Right now, my age array is allocated, but it's null. My name array, the same. It knows that there's going to be one. It doesn't know how big it is. Now I'm going to do the step into, and we should see now our name array allocated. So we could click the disclosure triangle there and see all of the entries in our array with their index values. So that can be really, really helpful to us. So now I'm going to step into again, and my age array should now have a size. It's now dimensioned. It knows how big it is. But if I click the disclosure triangle, I just have all zeros. It's not really got the values yet. So I can step into and see all of the values get set into our array entries. Now I'm going to call the method output arrays. So when I step into, I should see my output arrays method start running. And now my array names are a little different. Ages and names, because we made those names a little bit different. We set up our index, go into our for each, let our for each handle our names array, but then we manually are handling our age array. You can step into and watch that for each loop execute each time as it goes through all the entries in your array. And then we're finally at the end. We did our output. Now if we step into, we should see the update process run. We did everything manually here, so we can watch the value of I change. See it check the condition, update the value of I, check the condition. And then finally, we could run our output again. So it looks good. I'm going to stop that. But your debugger is just super helpful when you're working with arrays, especially if you get an index out of bounds error, because a lot of times you can use the debugger to figure out exactly what's happening and how that got out of bounds and what all happened. Okay, questions about our examples?
So, like in Python, you could modify arrays dynamically. So there is a way to do it, just not with this.
Not with arrays,
Okay.
with a different class,
Okay.
with a different class type. So if you think about it, think about how much code is required to dynamically modify an array size. C++, C#, don't, and Java don't automatically do that because of that overhead. So they just keep the array classes lean and mean as much as they possibly can, and then they add those special features. So we'll be looking at the array list. Will add that in. It's real easy to use, so it's not much different. We just like everybody to get used to the real limited one first, because otherwise you can get in trouble thinking that you can do something. Other questions about it? We have some pretty good examples, so try some stuff. The REPL, where'd I go? I didn't have it open. Has some good stop talking. Has some good talk stuff. I can never find them all. Do you think? I think that's all. Again, that's our last one. With this one especially, let me know if you're having trouble. You can skip them, but as you look, you'll see a lot of these start where the previous one left off. So kind of a hint, if you're totally stuck, go to the next one and it'll kind of start with the answer to the last one. So don't cheat, but be smart. All right, and just get to what you need. So we're going to be looking at several different things here, and each of these is super valuable. So this first shows you how to create an array with some values, access them, which should be a lot like what we just did, and then setting and accessing values, looping through. So everything should be very, very similar to our examples. Just gives you a chance to do it on your own. So let me know if you're having trouble so we can get you fixed. The classes array, or sorry, REPL, used wrong word there. There's one that was a few weeks back, and there was a few people that had trouble with it. Let me know if you need some help with it so we can get you through it, because it is important to feel a little bit more confident with that one. I'd like for you to get further. Any questions? Okay, I'm working on your REPL for a lab time. We don't have a lot of lab time, but I wanted to make sure we had some good examples. So, oh my gosh, it's like spring break after this for our class. So I hope everybody has a great spring break. Is anybody going anyplace good? Crazy? Did you see that? They said that everybody's going on trips because they were like, oh, we could go so cheap.
Yeah, yeah.
That would be something, wouldn't it? It almost makes it worth it because you just drive down there, you know, just never stop. Well, you'd have to stop a couple of times.
Fly down there.
Yeah, but when you get an airplane, you're in that floating petri dish is what they're saying. You know, my car is safe. I can spray Lysol. Lysol. Steve.
It's like $1 and $26 tax.
They have a value added tax, the price is still the price you pay. You know, it's like the 20-minute flight with each time.
One way.
Where are you going?
China.
How much is it?
It's like $251.
Right, that would be cool. I would like to go there. Where would be the coolest place to go? How much is it to be seen? I have that old man shirt. I should wear that.
I love the John Wayne one.
And then there's like $281.
Client, we should go from LA to Auckland, New Zealand.
They probably wouldn't let us in the country. They'd probably say no. You all know that. You dirty country. Where else would be super cool? I thought those people that walking around in Italy looked kind of spooky, but yet kind of cool. You know, I don't know if anything was open though to actually see anything. My daughter was in Philadelphia one time. We were in a blizzard, so she said it was all empty, but it was all closed.
9,000 people or households have self-isolated.
Oh, so they're just going to take care of it themselves. And here we are just acting like everything's fine. We're going to darn it, I hate that. They're sending emails and stuff like crazy. A teacher posted a great big giant post on the Facebook page last night asking about why we aren't.
New Zealand has 5 confirmed cases.
Oh, they do. That app just sticking on me, picking up now. Great spring break. Stay healthy, everybody.
The coronavirus is an accident.
Will you help me remember next time to? It's going to be a week, so I'm going to forget and you're going to forget. But last time, when you guys were showing your triangle, there were several people that said they had trouble overriding the 2-string. And I think it was because you have to use the uppercase string keyword. I think that's probably the only thing that people called wrong. I forgot to show everybody. Help me remember. You too. Have a great spring break.
Yes.
Fun. Yeah. I keep trying to remember. It seems early.
It's a Google Blueprint for an internship, and it's still open. Yeah. Cool.
Oh,
Yeah, rolls and dice. Okay, great. And if they have more attack than defense, they get hurt otherwise. Here we go.
this forever.
This is like a pseudo random.
Yeah. You can just hammer.
There you go. Yeah, they're so player one and second two. Player.
Are you trying to set hammer?
Is that a timer?
Is that anything?
So
I don't think,
yeah, I could.
yeah.
But I think we're sick of this right now.
Yeah,
Spent a lot of time.
yeah.
You do. Thanks. Have a good break.
But like, I did finish it. We went about more objects. So I tried to create like. Really, but the genius. I don't know why like the memory or something.
Did you use the right syntax for your class?
Sure. No, I mean, look like because like I mean, it's not the one. I mean, another one that like the way to accept the class object and then you change the actual element on the page right here. So it's like had the timer and the memory not enough like memory to like do the same time.
Yeah.
I had
a loop that wasn't set up right. So it's like the whole page froze.
not good.
And I had to close everything to work. That's not what I want.
Oh,
Show you. Yeah. I know how to show you that.
I went off.
Yeah, there's a lot of computer shortcuts.
What do we on summer?
For the summer, I'm probably now I'm like IT/personal assistant. So not only do I do some IT stuff, I also build things out and stuff like that.
We move forward on the
I'm looking at IT, the one I told you about is better than Walmart, a lot better than the Walmart I'm working at.
yeah.
I think any Walmart's better, to be quite honest, than Walmart we work at. You're very lucky too. Home office came out yesterday.
Yeah?
Yeah, they're talking about protocol for the coronavirus.
Oh,
because of the St. Louis outbreak.
We see people all the time in automotive going to from St. Louis.
Yeah.
So if anyone were to get sick or get coronavirus, it was from automotive.
Automotive, and then yeah. And what sucks is, I mean, we get penalized for not showing up. So I mean,
I
we're
mean,
gonna,
if you do a leave of absence,
which but at the same time, though, with a leave of absence, you don't get paid. And I mean, there's also that chance that they'll just deny it.
yeah, which is stupid. So here's my code. I need to, I'm
No, we
not
can't
sure
even mention the word.
made it efficient, but it's at like 271.
What is okay?
We have
It
to
worked
go
for
through
me.
that
That's
because
all I
of
care
the
about.
information and
But like all of this, I
we
feel like
learn.
I could make it more efficient.
For sure.
But we're not
Not
listed, so they can
able to
just do it anymore.
Like if I made a loop,
But if you feel that
Yeah.
like a loop through this, it would create the values of the brain.
But that not close. So we made a lot better. I mean, if we made a time more interesting. We need data.
No, I have an idea. So
Try it.
it's actually,
Was it on a lot of
I
kids'
use it
hands,
for
so
my game design. I had to create a prototype, so that was the first thing. And also,
they're trying to
using
run
my
this
job
one
as
for
a
That's way better.
I got part two to go.
How come to going?
Actually, not going to. Read.
Good job.
Okay, good. Last, yes.